Next, we are going to do division. The quotient of complex numbers is in algebraic form. So let me write down division. So we have z1 equal x1 plus I y1, and z2 is equal x2 plus I y2. Okay, so to divide by each other, z1 over z2 is equal x1 plus I y1 over x2 plus I y2. So in this case, we are going to use a denominator multiplying by conjugate to the denominator. Okay, which is going to be x1 plus I y1, x2 plus I y2. And conjugate, it's going to be x2, x2 minus I y2, and as we know, whatever change we do to denominator, we have to do precisely same change to numerator. Okay, so from here we are getting, this is equal x1 times x2 plus y1 times y2. So when we multiply I y1 times negative I y2, so let me show you here to drafting I y1 times negative I y2, we are going to get negative I squared, right? Y1 times y2, times y2. Now, because y squared is negative 1, so with this negative, we'll get positive y1, y2, right? Okay, so let me clean this drafting. Okay, we continue. Y1, the y2 divided by, okay, here we have our fractional line, and x1, x2 plus y1, y2, and plus I times x2 y1 minus x1 y2. That's in the numerator. If you multiply, that's what you will get. Now, in denominator we have, look here, I can place a plus b times a minus b, right? So it's a formula a squared minus b squared, which means we have x2 squared minus I y2 squared, right? Okay, so from here we have, I'm going to separate this real portion. I'm going to separate from imaginary portion. Okay, write down in the format of complex number in algebraic form. So which means we are going to have x1, x2 plus y1, y2 divided by x2 squared. Since I squared, so look here, I times y2 squared, we are getting I squared, y2 squared. So this is equal negative 1, which means this negative will become positive, and plus y2 squared, right? Okay. Next, plus I times x squared y1 minus x1 y2, and the same denominator because denominator is common. So if I'm separating, I have to keep the same denominator, plus y2 squared. So this is a template for quotient of complex numbers. So let's do example. Okay, so we have z1 equal 2 and obviously 0i, right? If we have only 2, so that's mean imaginary number is 0. And z2 is equal 1 plus 2i. So I chose a little bit easy case, so we won't get in too much of calculation. But since you have here given the template, when you do division, you can use this template, follow, and you will get the result. But here what we have. So practically z1 divided by z2, we are getting 2 divided by 1 plus 2i. Yes, this is equal 2 divided by conjugate of 1 plus 2i. So we need to multiply by 1 minus 2i. Just like when we do rationalize the radicals, right? If we have, let's say, 7 over square root, what we have, square root x minus 3, then we need to multiply and divide by square root x plus 3. So create x squared, a squared minus b squared, okay, to get rid of this square root. Square root x plus 3. Yeah? So this way here we will get a square of square root x, it's going to be x, and then minus 3 squared, it's going to be 9. Okay? So back to our problem. So we are going to do, yes, multiply by the same expression, 1 minus 2i, and we are getting 2 minus 4i divided by square root of 1 is 1. Here we are going to have minus 4i squared. Well, we know that I squared is negative 1. Yes? Therefore, we are going to get z1 by z2 is equal 2 minus 4i. So negative 1, I squared negative 1, which means it's going to be 1 plus 4. Or 2 minus 4i over 5. So from here I can separate, write down in the format of, in the form of complex number, we are getting 2 over 5 minus 4 over 5i. Next one, so this is example 1. Let's say this is example 2. So we will do division or find the quotient for complex numbers in trigonometric form. Okay, so let me remind you the division in trigonometric form, what result it should be. So z1 divided by z2, or you can write down in the form of fraction, doesn't matter, it's the same division, is equal r1 over r2. In parentheses we have cosine phi1 minus phi2 and plus I times sine phi1, oops, does it look like phi1 minus phi2. Okay, so this is the template we are going to use. All right, so let's solve, do the division for trigonometric functions. So we have z1 is equal square root 2 cosine pi over 2 plus I sine pi over 2. Okay, and z2 is equal square root 2 times cosine pi over 4 plus I sine pi over 4. Okay, so the quotient for these complex numbers all right, the quotient of these complex numbers z1 divided by z2 is equal r1 over r2, right? R1 is square root 2 divided by, because let me write down, this is r1, right? Cosine theta 1 plus I cosine theta 2. Here is r2 cosine theta 2 plus I sine theta 2. Okay, so which means r1 is square root 2 divided by r2, which is also square root 2, and times cosine cosine theta 1 minus theta 2, which is going to be theta 1 is half a pi and minus quarter of the pi plus I sine, again half a pi minus pi over 4. Okay, so from here we have this is gone, so we have left 1. We don't need to write down, and we are getting half a pi minus quarter of pi. It's going to be quarter of pi, because quarter of pi times 2, it's going to be half a pi, right? So it's going to be cosine quarter of pi plus I sine also quarter of pi, and this is going to be the quotient. Okay, and this is our answer for, let me write down here, z1 divided by z2, and this is our answer. Now in this case you can figure out that cosine and sine pi over 4 is square root 2 over 2, right? So you can replace it, but it won't be a trig form, it's going to be algebraic form, right? Okay, now let's find the quotient of complex numbers in the exponent form. All right, example 3. So for exponent form, the quotient of complex number is performed by the formula or template z1. Let me change the color so you will see it's different. Okay, z1 divided by z2 is equal r1 times e to power I phi2 phi1 divided by r2 e to power I phi2, right? So from here we are going to get r1 over r2, this is r1, and e to power, since we are dividing bases with exponents and bases are the same, so we need to subtract exponents, right? So it's going to be e to power I phi1 minus phi2. Okay, so here is our example. I guess this formula I can put in this format, and the rest we can do in the blue color. So you will see previously was trig format. Now you have exponential format. All right, so we have z1 equals square root 2 e to power negative pi over 2I, and z2 we have 4e to power negative pi over 4 I. Okay, so the quotient of rational complex numbers, z1 divided by z2, we are going to have r1. Okay, let me clean this. So this is my r1. Let me write down r1 is square root 2, r2 is 4, phi 1 is negative pi over 2, and phi 2 is negative pi over 4. Okay, so from here we have square root 2 over 4, so I'm following this formula, times e to power I, negative pi over 2 minus negative pi over 4. Yes? And this is equal square root 2 over 4 times e to power, so negative pi over 2, here is going to be plus pi over 4, right? So it's going to be negative pi over 4 times I. Okay, so from here, this is going to be our answer, that z1 divided by z2. Here we have square root 2 over 4 e to power negative pi over 4 I. So this is the answer. Okay. Let's do one more. Okay, or we will do the square. Okay, let's do square. I think this is good enough. It's pretty straightforward. So let's do the square. Changing here color on black. Square a complex number. So exponentiation, of complex number in a trig function. So for exponentiation, let me write down. For exponentiation of complex numbers in trigonometric form, we are using the formula that we call mover. Okay, which says z to power k is equal r to power k cosine k theta plus I sine k theta. Okay. And in the exponential form, the complex number using, the complex numbers are raised to a power using the following formula. Z to power k is equal r e to power I phi to power k, and that is equal r to power k e to power I k phi, and that's the formula for exponential form. All right, so here we have raising to power in trig function, in trig form, and here we have in exponential form. Okay, so let's solve example. We need to square a complex number. We need to square a complex number. Z is equal square root 2 e to power negative pi over 2I. Okay, so applying the formula for exponentiation, which is the second one in blue version, so we are getting z squared is equal square root 2 e to power negative pi over 2I equal square root 2 squared and then e to power negative pi, oops, here is square, e to power negative pi over 2 I times 2, right? Because we get power to power. Let me remind you, a to power n to power m. It's equal a to power n times m, right? Power to power. So we need to multiply. So, okay, let me write down here, square. Okay, so from here, we are getting z square is equal square root 2 to power 2. It's going to be 2. And we are going to get 2. We have already 2 e to power. So let me see, this 2, it will be cancelled with this 2. And the answer is going to be negative pi I. And this is going to be our answer. Okay?